Hello everyone, my name is Naveen Joy and I'm one of the core developers of the networking VPP project, and that's what I'm here to talk to you about. It's in fact a scalable neutron ML2 mechanism driver for VPP. Now what exactly is VPP? VPP is an out-of-the-box production quality vSwitch and a vRouter. Although for the purposes of this project, what we are utilizing it is as a vSwitch. And what we are doing is we are integrating it with the Neutron L3 plugin. So you get all the benefits of VPP, which is a highly scalable and high-performing switch platform, along with the Neutron L3 integration. VPP stands for Vector Packet Processing Technology. It has been originally developed by Cisco, and it has been in use since a long time, and we have open sourced it. The difference is that it is a very high performing packet processing, and that is what distinguishes VPP from other switches in the market. We have seen throughput of greater than 10 gigabits per second, full duplex on a single x86 host, and it is very good at forwarding really small packets. That makes it very good for your NFV applications. You can also run it on commodity x86 hardware, and it runs in the user space, which means that you can upgrade VPP, install it. You can do all of that without rebooting your platform. So if you have any source code management or any software management tools, you can easily roll it out to all of your infrastructure pretty fast and get it going or upgrade it without having to impact your production operations. You can retrieve more information at wiki.fd.io/viewvpp, and also you can look at the source code. It is fully open source and it's hosted at fd.io. Now what is networking VPP? Networking VPP is a mechanism driver which functions as a control plane for VPP. VPP being that virtual switch, what we wanted to do was to make it much more easy to consume. So you have OpenStack with all its APIs that enables the creation of ports, network subnets, and so on. So now with the integration with OpenStack, you have the ability to drive VPP through Neutron APIs, and you can integrate it with a lot of other projects as well. So it's a very simple implementation, offering a roadmap to full Neutron functionality. And if you want to look at the source code, it's an open source project. In fact, it is inside OpenStack, excuse me, and you can access the source code at OpenStack/networkingVPP. So what are the main software components of VPP? There are three. One is the ML2 networking VPP mechanism driver itself. And this is the code that implements the Neutron ML2 mechanism driver APIs, basically creating the ports and then having, when you make that call, what the mechanism driver does is that it creates the port within VPP itself. You don't have to know any of the internals of being able to do that within VPP. The driver, and using Neutron APIs, you'll be able to easily consume a lot of the capabilities presented by that vSwitch. It performs port binding. It runs on the controller as a Neutron ML2 driver, basically QSVC. So you just replace the driver, like if you're using the OVS mechanism driver, replace it with a networking VPP mechanism driver, and you'll be ready to go. Then the VPP agent. This is the program that runs on each compute node, and it programs the VPP data plane itself. So when you make a Neutron call to create a port or do anything with that, the VPP agent receives the call, and it actually talks to VPP using its Python APIs and sets up the vhost user sockets, etc., to talk to the VMs. Then finally, we have the HCD cluster. It's a distributed key value store and stores state data, and it provides a messaging framework. You may have heard about RabbitMQ. So we decided to use HCD primarily for its simplicity, and it suits the framework or the model that we are trying to implement. in terms of the publisher-subscriber, the subscriber-consumer model. And the HCD cluster, you can run it anywhere. Typically, we are running it on the controller node. So this diagram shows the details of port binding with VPP. On the left-hand side, you can see Nova Compute. In fact, yeah. And when you launch a virtual machine, what Nova Compute does is it sends a bind port call to Neutron. It basically calls the Neutron APIs. And since we have the networking VPP mechanism driver, our driver receives that call. And what it does is it sends a request to HCD. So we have these agents, VPP agents, that are running on the compute node. And when you start this agent actually listens to HCD, the key value store. Basically, you have this watch. You can watch that key value store for changes and receive notifications when a value changes. So the bind port call, the ML2 mechanism driver injects data into HCD, basically telling VPP agent running on the compute node, go ahead and drop a vhost user socket for the VM. So the compute node receives that notification, programs VPP, and then what it does is it sends data back to HCD, communicates back to the mechanism driver, telling that I have dropped the socket, and the mechanism driver now notifies Nova, saying that the port provisioning has been complete, and Nova then proceeds with the virtual machine creation with QEMU. So this is a high-level flow of how things would work with networking VPP. One point to note here is that we are using Neutron DB as the source of truth, which means that when you send a bind port call, that call is initially stored inside Neutron DB, and we have actually a background thread that takes that information and injects it into HCD. So the data in HCD is kind of lagging behind the data that you inject into Neutron DB. But that's the way it should be. Eventually, it'll be consistent. So when you create a port, data comes into Neutron DB. From there, it goes into HCD. We have the compute node agent that receives a notification. It creates the socket, tells the agent that it's done, and the agent notifies Nova. This is a high-level layout of the HCD key value store. So we have networking VPP/nodes is a directory that is set up. And for each compute host, we have a directory set up for ports. So every time you create a port, the driver sends that port data into this store, in fact, this directory, with the key of that port ID and the value that is required for the agent to create that socket. Similarly, the agent, after creating the socket, writes back its state to the state directory. And that's where the driver would pick it up and send a notification to Nova. So how do you get started? Set up your devstack. So we have a devstack plugin. It's available to you. It's right here at OpenStack/networking VPP. So you can add to your local.conf, and then you can stack your devstack. A very good place to start is the readbe. So it describes the overall architecture in detail, pretty much what I just talked about. And we also have the VPP installation steps for both CentOS and Ubuntu platforms. So how to install the VPP Python API bindings. So the agent that is running on each compute host talks to the VPP forwarder using its Python APIs. So you'll have to get that installed too. And then you can use our sample local.conf to get your stack going. This is a single node devstack scenario. So you would run all of your core OpenStack services, such as your Nova and your Keystone and Glance and so on. Then you will have HCD and then Neutron ML2 service. with QSVC, with networking VPP as the driver. Then you have other services such as the metadata service, the L3, DHCP, and the VPP agent that is running on that node. And the platform VPP, the virtual switch itself, is running on that single node. So if you want to set up a multi-node devstack scenario, you can use this template. You have the controller node that runs the HCD, which is the messaging platform that we're using, and then the Neutron ML2 service and other core OpenStack services. Then the network node would run the VPP, control the data plane and the agent, the Neutron metadata, DHCP, L3, and so on. On the compute node, you will run the Nova compute and the VPP agent itself. So what do we support today? We support VLAN and flat networking, vhost user ports for VMs, tap interfaces for services such as DHCP and L3, integration with Neutron DHCP, Neutron L3, floating IPs, and driver and agent restart scenarios. Basically, if you restart the agent, it's intelligent enough to continue from where it left off. So I would like to also give a shout out to a couple of my colleagues, without whom this project would not be possible. Ian Wells, who is the PTL for this project, and also Jerome Tollett. They helped a lot in being able to drive this project to where we are right now. So if you're interested to learn more about this, we have 2 additional sessions. So VPP, the ultimate NFV switch, and more on Thursday at 9:50 a.m. And Cisco ML2 VPP, blazingly fast networking for Neutron, on Thursday at 11:50 a.m. So if you're interested, these are very good sessions to check out for more information. Thank you so much.